Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 3 from Chapter 9, which is looking at quadratic inequalities in two variables. So we're going to look at graphing the quadratic inequality in two variables, and we're going to use a method similar to how we graphed a linear inequality in two variables, which is what we saw in the last video. One point to remind yourself about is that we need to make sure we use our test points when we're shading. So we're going to take the same kind of approach to graphing quadratic inequalities as we did with the linear inequalities. So we're going to graph the equation as if it were just a regular equation, and then the inequality will tell us whether or not we're using a dashed line or a solid line, and then we'll also use a test point to determine which side of the graph we're going to shade. So there are quite a few different possible, kind of looking graphs that you can have. And really they just depend on whether or not you're shading above or below your quadratic function and whether or not they have a solid or dashed line. So here are just 4 examples of solutions that we might have when we're graphing quadratic inequalities. So here we could have a graph going up but shading below, and here we have a dashed line. We could have a dashed line that's opening down and we're also shading down. We could have a solid line but graphing below our parabola, and then solid line and graphing down. There's a few other possibilities, but these are just some examples of what our quadratic inequalities graph might look like. So as I said, we're going to take a very similar approach to graphing as we would with the linear inequalities. Just this time, instead of a straight line, we're going to be looking at parabolas. So we're going to look at example number 1 from your notes. So here we're going to graph the quadratic inequality y is greater than or equal to -2 times x minus 3 squared plus 1. So just like in our last video, our first step here is we're going to first identify whether or not we're going to have a solid or dashed line. And in order to determine that, we just have to look at your inequality symbol. If it has an equal to symbol here, then that means that it's going to be a solid line. So make sure you write that down, that way you don't forget that it has to be a solid line rather than a dashed line. Then our next step is we're going to write this inequality as an equation. So here we have y is equal to -2 times x minus 3 squared plus 1. So we're literally just going to replace this inequality with an equal sign. Then what we're going to do is we're going to graph this y is equal to -2 times x minus 3 squared plus 1. And because this one here is a quadratic, the first thing that we need to identify when we're doing our table values is that vertex. And one really awesome thing about this equation is that we're given this equation in vertex form, meaning we're given the vertex within that question. So if you guys remember back to chapters 3 and 4, this equation here is given in vertex form. So we have an a value, we have a p, and we have a q value. Your vertex is at point P and Q. And one thing that's really important to remember is that in our question, or I guess in our little equation here, you have to take the opposite value of P. So if P here is negative, or here if you see x minus 3, then your P value is positive 3. So P is positive 3, and then Q is just the regular value, so it'll be positive 1. So our vertex is at 3 and 1. Then we can use this to create our table values. So we're going to have an x and y table values. And then our vertex is going to go in the middle. So we have 3 and 1. Then what we're going to do is we're going to choose a couple of values above, a couple of values below, just so we have a nice good spread table values there. So we go a couple below, so we go down 2 and 1, and then go up to 4 and 5. Then I'm going to find my y values. So every time I see x, I'm going to put in these different x variables, or values, sorry, and then find out my y. So every time I see x, I'm going to put in 1 instead here. So my equation was -2 times be x, so 1 minus 3 squared plus 1. So solving inside my brackets first, I have 1 minus 3, so it'll be negative 2 times 1 minus 3 is negative 2, that is squared, plus 1. Negative 2 squared is 4 times negative 2 is negative 8, plus 1 would give you negative 7. Then we're going to do the same for x equal to 2. So we have negative 2 times 2 minus 3 squared plus 1. 2 minus 3 is negative 1. So we have 2 times negative 1 squared plus 1. Negative 1 squared is just 1 times negative 2 is negative 2. And plus 1 gives you negative 1. Now, as long as we do our work right, our value should start to mirror because here we're at our vertex. So if we do our work right, the y value for x equal to 4 should be negative 1, and for 5 should be negative 7. But we're going to redo that work anyways just to make sure we did our math right earlier. So we have x equal to 4, so we're going to have negative 2 times 4 minus 3 squared plus 1. 4 minus 3 is positive 1. So we have negative 2 times 1 squared plus 1. 1 squared is 1 times negative 2 gives you negative 2. Add that with 1 and we get negative 1. So here we have those matching y values, which is how we know we're on the right track. Then we have x equal to 5. So we have negative 2 times 5 minus 3 squared plus 1. 5 minus 3 is 2. So we have negative 2 times 2 squared plus 1. 2 squared is 4, and 4 times negative 2 is negative 8. Then plus 1 would give you negative 7. So once again, we have those matching y values. So it tells us we're on the right track. So then what we need to do next is we need to label our spacing for our graph. So when we're talking about the x-axis, we just need to make sure we show the smallest number there could be x equal to 1, and then we have to make sure we fit 5 though on that graph. So looking above here, there are 10 lines going from your origin to the end of your graph. So we could really do every second line as 1 here. And then we want to look at our spacing for our y values. So our biggest value here is 1, and then that smallest number, that negative number there, is negative 7. So we need to make sure we fit up to, or I guess as low as, negative 7 on your graph. So if there's 10 lines, you probably want to go every line as 1. And I'm just going to label every second one. So then we can go ahead and start plotting our points, and just keeping in mind here that it is a solid line. So it's nothing new compared to what we've done before. So we'll start with our first point. We have x equal to 1, y is equal to negative 7. We have x equal to 2, y is equal to negative 1. Then we have x equal to 3, y is equal to 1. Looking down here, if we had x equal to 4, y is equal to negative 1. Then x equal to 5, y is equal to negative 7. So then I'm going to connect all my points here. Make sure your parabola should have a nice smooth U-shaped curve. And hopefully your hand is not as shaky as mine is. And make sure you put some arrows at the end of your graph. So I might even want to fix this one up here just a little bit. So I want to make sure it goes through our points. And I cannot seem to get it on my writing pad here. Okay. So we have a solid line. We have our U-shaped parabola. So then what we need to do, our last step here, is to figure out where we're shading. And so to do that, you're going to use your test point. So to choose your test point, you can really choose any point that your heart desires, but we like to keep things easy in math. So if you can, you're going to choose that point 0 and 0 and plug it into your inequality. So we're going to test 0 and 0. So you're going to put in 0 for x, 0 for y. So you would have 0 is greater than or equal to negative 2 times 0 minus 3 squared plus 1. Then we're going to solve inside those brackets. So 0 is greater than or equal to negative 2, and 0 minus 3 is negative 3. That's squared plus 1. So negative 3 squared is positive 9. And then 9 times negative 2 is negative 18 plus 1. So 0 is greater than or equal to, and negative 18 plus 1 is negative 17. So then you can ask yourself, is 0 greater than or equal to negative 17? And that is true, which makes 0, 0 part of the solution region, which means that we need to shade that area. So going back here, I want to shade the side where 0, 0 is. I'm going to shade here, and you can shade basically the rest of this area that is above that parabola. And I'm using a ruler here. You just might want to do a nice light shading on your pencil. So you want to make sure that you can still see that x and y axis labeling. That you don't cover any other kind of important information up. So once when you're all done your shading, you guys have fully completed that question, you guys are ready to move on. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.